Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's newsletter, well, we're going to take a look at the new product introduction process and how all the tools in Six Sigma should be used in a process. You know, one of the problems, so we're gonna take a look here at new product introduction. One of the problems with training, Six Sigma maybe, is that what you tend to do is you tend to learn these tools all individually. Before I went and got trained as a Six Sigma black belt, I'd learned various tools in my career. Things like, I'd been on an FMEA course, by the way, never used it. Okay, so I've been on an FMEA course, never used it. I'd learned about 5S, didn't really use it. I'd learned about SPC, didn't really use it. Cause and effect, fishbone diagrams, call them what you like, didn't really use them. And one of the reasons was I just learned them as individual tools. Just went bang FMEA, bang SPC. And to be quite honest, when you just learn one set of tools like that they're going to have a very limited impact on what's going on. Really, what should be going on is right from day one. You know, Six Sigma shouldn't exist if you do this properly. So for instance, I've said this before, Toyota won't do Six Sigma. Why don't they do Six Sigma? Because they do this really well. They don't need big projects. They don't need to dig themselves out of big holes, because they use all the tools properly and they get a product and a process that's designed correctly so that it's fully in control and it produces from day one. So let's go through this. So as a sort of set of steps, the first one, of course, the design FMEA, would be the first, probably the first document that's going to get done. The design FMEA is supposed to talk to the process FMEA. So what the design FMEA is doing, this is turning the voice of the customer. So up here we've got the voice of the customer, and the voice of the customer goes into the design FMEA such that all the tolerances and the design intent sit in here. This is the designer's thought process. The designer's thought process then, of course, passes all the information like tolerances and surface finishes and things like that into the process FMEA. So now this is the working document of the process engineer. So the process engineer has to design the process. He has to decide what machine that it's going to be used and what controls are going to be put in place. How does he do this? Well, he should do it with the process FMEA. The process FMEA isn't just a list of extreme events that may or may not happen, a set of accidental events. The process FMEA is supposed to take you through every step of the process and ask you what could go wrong and how you're going to control it. So what comes out of here? What comes out of here are your process controls. A control plan should come out of this. Should come out of this if it's done correctly. Now, once of course you've designed the process, now what you're going to do is you're going to move to doing real things now. So first thing you're going to do pilot run. Now you might do prototypes before this. I appreciate there might be some prototype work up here, but we're assuming that the product's got designed and we're going to make the item. Now, going to do a pilot run. Now, some other tools that you're going to use. The first thing, you're going to use your sample size calculator, because straight away it's got to be a minimum of 30 to 50. might even be more than that if what you're trying to assess are pass and fail quality characteristics. But the pilot run is going to use your sample size calculator. We're going to go at least 30 to 50. And then when we start looking at dimensions, what tools are we going to use? Well, we're going to do this. We're going to go run chart. First one. What does this thing look like? Yeah, so we're going to go run chart. By the way, something else about the pilot run. 30 to 50, hands off. Don't touch the process. Don't touch the process. We want to see real data here. We want real process information. You can only get that by taking your hands off. Okay, so we're going to go run chart. Then we're going to go histogram. This is the next one we want. We're going to take some pictures here. Run chart. What does this thing look like? Run chart, histogram, and then finally CPK diagram. Now I'm always going to use these three together like this. If I've got measurable data, tolerances that I'm trying to work out the capability, can we make the process, can we make the product okay? It's a really important question to ask before you switch the process on live and create piles of scrap and chaos. Okay, so the last one, CPK diagram. Yeah, are we capable? What kind of defect rate do we have, etc. Yeah, so CPK diagram, run chart, histogram, CPK. Now, once I've established that I have a capable process, of course, now what I'm going to do, I'm going to lock all of this good stuff in. I'm going to lock all my process controls in now for the next 5 years, because we're going to run this process successfully for the next 5 years. So now, out of the process controls here, where are we going? We're going to the point of activity, and I'm going to put some visual controls in. I'm going to make everything visual. Why am I going to make everything visual? Because if I make everything visual, then my ISO 9000 will work, because I'm going to do audits on these controls that keep the customer happy. Think about it. Why do you do this? You do this not to put a certificate on the wall. You do it to keep the customer happy and to make pots of money. That's what ISO 9000's for. It's not for certificates. Okay, so we're going to visualize the standards. We're going to do regular process audits, and finally I'm also going to use statistical process control, because I can't understand my process properly without SPC. I can't set the process up properly and effectively without SPC. SPC is a fundamental. It is not a nice to have. I know that in ISO 9000 it says use this if applicable. It's always applicable. I don't know why you'd even say that. This is a must-have tool to make the most amount of money. So look at this now. These tools all work together. These are tools that sometimes you don't like. FMEA, it's hard yards to get an FMEA done. Yeah, it's like wading through treacle. And you've no idea why you did it. Why did you do it? To produce a process that works right off the bat. First blow of the day. Yeah, that's why you do an FMEA. It's to get great process controls. Then you need to test that you've done this well. It's not saying you're going to get this right first time, but you're going to go run chart, histogram, CPK. What's your CPK doing? Really important. It is going to predict the future defect rate. This is again a really important tool. If you look at the histogram, let's put some tolerances on this thing. If you look at the histogram and everything is defect free, and you assume that because your pilot run is defect free, if you assume that the history is going to be defect free, the future is going to be defect free rather, you will be making a big mistake. This is going to predict results you didn't capture in your pilot run. It's going to say there's more extreme results out there. So it's going to stop you from blundering into a situation where you thought the process was going to be fantastic. You switch it on, it makes piles of defects, and now you're in chaos. And by the way, what do you do next? Well, you get a Six Sigma project running and you get a team of people and you take 3 months to put it right. Yeah, because you've dropped yourself in a mess. Six Sigma projects should never exist, because you should have done this brilliantly. You should have been very intelligent about the way your process capability is going to work. And because you're very intelligent, you get this right first blow on the job. And now, for the next 5 and 10 years, what do? You just make piles and piles of money. That's because you know how to use these tools as a collective, as a process. They don't come as individual tools, and they are not a nice to have. All of these tools are fundamental. Use them well, use them together, and make piles and piles of money.